The objective of this tutorial is to get a common understanding of the terminology we will use in future tutorials, and we are currently focusing on the user interface of the CNC, the components that the operator sees, and the maintenance engineer uses as a diagnostic tool. The three main components of the user interface are the CNC display, which we discussed in an earlier tutorial, the MDI panel, the topic of this tutorial, and the machine operator panel, the topic of the next tutorial. If the CNC display is a screen just like on a PC, the MDI panel is very similar to a PC keyboard. MDI is an abbreviation of manual data input. In other words, it's where the operator or maintenance engineer inputs information into the CNC. An MDI panel has many of the same keys as a PC keyboard, including alpha keys, numeric keys, cursor control keys, edit keys, and some function keys. The increasingly popular Qwerty MDI panel from FANUC looks very similar to its PC cousin. However, many FANUC CNCs and most legacy FANUC CNCs use an ONG MDI panel. It is called the ONG MDI panel because the first three letters on the top of the keyboard are O, N, and G. If we know something about CNC programming, we may notice that all the keys on the ONG keyboard are listed and grouped in the order they will likely appear in the program. This ONG MDI panel is for a machining center CNC. Most legacy part programs and many current part programs begin with the O letter address that identifies the program in the CNC. Historically, the N letter address labeled individual blocks, but they are used less often today, especially with programs developed on CAM systems. Most program blocks begin with a G-code command. The G-code command is often followed by some axis positions, typically X, Y, and Z for a machining center. Arcs were traditionally programmed using their center positions, specified with the I, J, and K letter addresses. But today radius programming is more often used, specified with the R letter address. Blocks continue with M codes or miscellaneous codes to control machine auxiliary functions, S codes to set the spindle speed, and T codes to select the active tool. F codes set the feed rate for an interpolated axis move, and the D and H control tool offsets on a machining center. Many other letters in the fourth column are used in CAN cycles and custom macros. A turning CNC has a different ONG keyboard. The first line is the same, but the common axis letters on a lathe are X and Z for absolute moves of the main axis, and C for a C-axis positioning spindle. The inclusion of the Y letter address recognizes the fact that Y-axis lathes are becoming increasingly popular. On a lathe, incremental axis moves are mostly programmed with the U, W, and sometimes V letter addresses, and only the I and K are needed to specify traditional arc centers in the XZ plane. The increasing popularity of the Qwerty MDI panel is due to several reasons. The new generation of operators have grown up with computers and are comfortable with the Qwerty key layout. The increased use of network communications demands a full set of keys, and the distinctions between turning and machining center machine tools is blurring. Now many lathes are capable of machining with live tools, and an increasing number of hybrid machines can perform milling and turning on the same part with independent axes and paths. So a full set of keys are becoming increasingly important, and the ONG keyboards are more difficult to use in these environments. So let's start with a detailed look at the FANUC Qwerty MDI panel. The first set of keys we must master on the MDI panel are the function keys. On the Qwerty MDI panel, they are placed at the top, similar to the function or F keys on a PC keyboard. The function keys allow the operator to quickly select a set of screens. In the previous tutorial, we introduced the soft keys that are part of the CNC display and allow us to move between the various pages available. Currently, this CNC is sitting on the position function pages, and in particular, the absolute position page. The position function key selects the position pages, and soft keys allow you to choose between absolute position, relative position, and the All Positions page. Note there is no plus sign on the continuous menu soft key, so this is all the choices available under the position function. The program function key selects the program pages. We saw all of these pages before in the previous tutorial. To review, the soft keys provide the choices between Program that lets us view and edit the program, Folder that displays the current folder where the registered programs and subprograms are listed, Next is a combination of the position pages, and it also displays the current and next program blocks, and Check a combination of the position page and the program page. Note we now have the plus character above the continuous menu soft key, reminding us that we have more choices, which in this case is the program restart screen. The offset and setting function key selects tool and work offset screens and a series of setting screens. Choices include the tool offsets page, the settings page, and the work offset page. Pressing the continuous menu soft key, we now see choices for the macro variable screen, the pattern menu screen, and the software operators panel. Pressing the continuous menu key again shows the language select screen and the guard or error prevention screen. Note that the guard soft key is displayed in green, indicating that pressing that soft key will take us to a lower level in the menu tree. When we press the guard soft key, the choices all change, and we get a choice of several error prevention soft keys, and the continuous menu soft key plus sign has gone. We have guard, which is several check the box settings, offset, that sets limits on tool offset values entered, work external, which sets limits on external work offset values entered, and work, that sets limits on the G54 through G59 work offset values entered. To return to the main offsetting setting function menu, we need to go one level up by pressing the menu return soft key. Pressing the continuous menu key one more time, and we're back at the original set of choices. Pressing the message function key provides choices between displaying alarms, messages, and the alarm history. We'll skip the other soft key choices for now. Pressing the graph function key displays the standard FANUC graphic function, providing a visualization of the motion of the tooltip. The first soft key specifies parameters for the graphic function, and the other soft key displays the graph plotting screen itself. The Custom 1 and Custom 2 keys are available for Machine Tool Builder's custom screens, and we have none in this example. The System key is very important for maintenance. First, we have a choice of viewing system parameters and a variety of diagnostic screens. The next two choices, Servo Guide and System, are again displayed in green, indicating pressing either of those soft keys will move to a lower level in the menu system, just like when we pressed the Operation soft key or the Guard soft key previously. The Servo Guide soft key takes us to the Servo Guide Mate soft key menu, providing a variety of servo tuning tools. More on these in a later Maintenance Workshop tutorial. To return to the main system, we press the Menu Return soft key. The System soft key displays information about the various hardware and software installed in the CNC. Moving on, there are Servo and Spindle setting pages, PMC pages, and the All I/O page. Next, the color setting page, periodic maintenance pages, waveform diagnostic page, and a lot more tools that we will visit in detail in later CNC maintenance workshop tutorials. Going back to the left side of the MDI panel, we have the Help function key that provides access to the Help system. It includes several topics related to the CNC and may be customized by the machine tool builder to include machine help. That was a quick overview of the function keys on the MDI panel. Note the same function keys appear on the ONG keyboard, they are just in different locations. We should also note these function keys were not provided on some very old legacy FANUC CNCs, and the function key selections were provided by another level of soft keys. One very special key on the MDI panel is the Reset key. This has many functions within the CNC and in the machine tool builder's ladder interface. One of the functions is to clear an alarm. Here we are on the position page and an alarm is indicated. Pressing the message function key and with the alarm soft key selected displays the alarm. It tells us we have enabled the ability to edit system parameters. By the way, if we now press the Help function key, we see the first item on the Help menu is Alarm Detail. We can either press the Alarm soft key or the Input key to select that choice. As you can see, the CNC knows which alarm is active and displays more information about the SW1 under alarm. It says parameter 8900 bit 1 is set to a 1, which is the system parameter edit enable bit. We can actually set this parameter more conveniently on the settings page, but more on that in a later tutorial. To clear the alarm, we must press the Reset key on the MDI panel. Pressing the Reset key performs many actions within the CNC and the machine tool builder interface. We must be very cautious when proceeding after pressing the Reset key, because many commands are cleared to their default states. More on Reset in a future tutorial. Next, we'll take a look at the cursor keys. Let's first select the Tool Offset page. Here we can see tool geometry and tool wear offsets for tool lengths and tool radii. This is a machining center control. We can see data sets for tool 1 through tool 16. To see more data sets, we press the Page Down key. Now we see data sets for tool 17 through tool 32. Pressing the Page Up key returns us to the previous page of tool offsets. Pressing the Page Down key repeatedly takes us through all the available tool datasets, 400 tool datasets in all. Until we finally wrap around and we're back at the first page. Pressing the Cursor Down key moves the cursor down one line at a time. Pressing the cursor up key moves the cursor up one line at a time. Pressing the cursor right key moves the cursor right one column at a time, and pressing the cursor left key moves the cursor left one column at a time. So these basic page up and down and cursor keys work just about as we'd expect them to, based on some experience of moving the cursor around a spreadsheet program on a PC. However, there are some differences when you get to the end of a column or line. If we cursor right to the end of a line, pressing an additional cursor right key moves the cursor to the first column of the next line. Here we are in the last column of Tool 5 dataset. One more cursor right key push moves the cursor to the first line of the dataset for Tool 6. Similarly, if the cursor is on the last line of a page, here on the first column of Tool 16, pressing the cursor down one more time places the cursor on the top line of the second column of the tool dataset for Tool 1. Now let's see how the cursor keys work in a part program. Here we have a program displayed. We can see the program identification block beginning with the O number. It is followed by blocks N10 through N210. The program is displayed in two columns on this 10.4-inch display. Pressing the page down key displays blocks 220 through 390. Another page down key displays the last blocks in the program, from 400 through 420. Pressing the page down key again does nothing. It does not return us to the first page of the program. Page up moves to the previous page in the program, again just like a PC editor. However, if we use the cursor right key, note that the cursor is highlighting one complete program word at a time. Comments in the program, which is any text between parentheses, is treated as one word. The end of block marker, which is displayed as a semicolon, is also a word. Pressing the cursor down key moves to the next line in the program, again selecting a word at a time. This is definitely a bit different than a standard PC text editor, but it is the traditional CNC editor and the only program editor available on older legacy FANUC CNCs. However, the FANUC Series 30i, 31i, 32i, 35i, and the 0iF provide a character editor that is just like that on a PC. To select the character editor, we press the Operations soft key, press the continuous menu key one time to display the Change Editor soft key, and then press that key. Note a couple of things happen immediately. All the spaces between the program words disappear because they're not actually in the program. The CNC inserted those spaces between the words to improve readability. Programmers leave out the spaces because they perform no function and would use up valuable part program storage space. The second thing is that the cursor now only highlights a single character, just like on a PC. And now the cursor keys move the cursor left, right, up and down one character at a time, again just like a character editor on a PC. If we start typing at the cursor position, text is immediately inserted into the part program at the cursor position and does not go via the CNC key input buffer. If we press the cancel key on the MDI panel, it works just like a backspace key on a PC. You may find the character editor is especially useful for editing comments and complex custom macro statements in a part program. I find it a little less efficient than the traditional CNC word editor when editing everything else in the program, but it may be a matter of personal preference. Give both a try and make your own choice. If we switch back to the word editor by pressing the Change Editor Operations soft key again, we can explain the MDI edit keys. You don't have to understand programming to understand the editing keys, but let's say we want to add a comment after the first line in the program to indicate that all the code up to N100 is establishing initial conditions. Remember, a part program comment is any text between parentheses. Let's add the comment start program. The first thing to know about the word editor is that text is inserted after the current cursor position and not at the current cursor position like a PC character editor. So to insert something between the end of block character on line 1 and the N10 on line 2, the cursor must be positioned at the end of the line, in this case on the end of block character on line 1. So with the cursor correctly positioned at the end of the first line, let's type in our comment. First we must enter the open parenthesis character. Note that the open parenthesis character is a shifted character on the letter I. This brings up another difference between a PC keyboard and a CNC MDI panel. Operators rarely have a keyboard in a position that encourages speed typing, like that taught in keyboarding or typing classes. With a keyboard vertical, it's much easier to press one button at a time. To enter a shifted character on the PC, we hold down the Shift key while we're pressing the key that enters the shifted character. However, on the MDI panel, we first press the Shift key and then release it completely. We do not continue to hold it down like we do on a PC. Next, we press the key with the shifted character we want to enter, in this case the I key. See, the parenthesis is inserted in the key input buffer. Now we can enter the text of the comment. We enter start, and then, oops, where is the space bar? Again, the space character is rarely entered in a word-based program editor, so on this MDI panel, the space is another shifted key, in this case on the M key. Press the Shift key, then release it, then press the M key. Now we enter the rest of the text, P-R-O-G-R-A-M. To enter the close parenthesis character, we again press the Shift key and release it, and then press the O key. All of the text is sitting there in the key input buffer. It will only be transferred to the program after we press the Insert key. We can freely edit the text in the key input buffer without making any changes to the program. Let's say we want to add the word my between start and program. Cursor left a few times until the key input buffer cursor, that is the underlying character here, is just to the left of the word program. Enter the new text, M, Y, and the space character. We review and decide no, we liked it the way it was. Cursor back until the key input buffer cursor is again just to the left of the word program. Press the Cancel MDI key to delete the characters we just entered. When it is just like we want it, we press the Insert MDI key. The text is inserted at the beginning of the N10 line. It's not quite what we wanted because this comment should be on a line by itself. The word cursor is highlighting the comment we just entered, so any inserted text will now be inserted after it. The character that marks the end of a line in a part program is called the end of block. Though it is displayed as a semicolon in the editor, there is a special end of block key on the MDI keyboard, labeled EOB. We press the EOB MDI key, confirm the character in the key input buffer is what we want, and then press the Insert key. Now the comment is on a line by itself in the program, which is what we wanted. Let's say we now want to alter the text in the comment. We highlight the comment in the part program using the cursor keys and enter a completely new comment. Start my program, for example. Confirm the text in the key input buffer is what we want, and press the Alt key on the MDI panel. Note that the text in the key input buffer replaces the highlighted word in the program. Let's say we decide to get rid of the comment altogether. Pressing the Delete key on the MDI panel will delete the highlighted word. Pressing Delete once deletes the comment and highlights the next word in the program, in this case the end of block character. Pressing Delete again deletes the end of block. Now we're back where we started. Let's type our comment again, including the EOB character, double check the key input buffer, and then press the Input key. In this case, the Input key worked just like the Insert key. Let's enter 2 more comment lines. We enter line 1 EOB, and line 2 EOB, review the key input buffer, and press the Insert key. The 2 lines are entered into the part program in one go, so we're not limited to entering just 1 line in the key input buffer. In fact, we can enter up to 128 characters at a time in the key input buffer. Remember that we can position the cursor within the key input buffer and press the Cancel key to delete 1 character. We may suppose by pressing Delete key would delete a single word. Let's give it a try. In fact, pressing Delete with the cursor in the key input buffer clears the key input buffer completely. So let's review. The Insert and Input keys inserts the text currently in the key input buffer into the program after the highlighted word. The Alt key replaces the text highlighted in the program with the text currently in the key input buffer. The Delete key deletes the highlighted word in the program or clears the key input buffer completely. A combination of the cursor keys and the Cancel key are used to edit the key input buffer 1 character at a time, before the Insert, Input, or Alt keys are used to transfer the current contents of the key input buffer into the program. Before we take a look at the differences on an OMG MDI panel, noted all the shifted symbol characters available on the Qwerty keyboard. It certainly includes all the ones we use in mainstream CNC programming and most of the common ones we use on a PC keyboard. Also, some legacy FANUC CNC controls have a full alphanumeric keyboard, but the letters are listed in A, B, C, D, E, F, G order rather than the Qwerty PC standard. The OMG keyboard is smaller than the Qwerty keyboard, and that is one reason some manufacturers still prefer it on smaller compact machine tools. In fact, the OMG keyboard is often mounted to the right of the CNC display. With only 20 of the 26 alpha character keys available, some of the shifted states of the keys are used for the letters E, C, U, V, W, and A on this machining center example. That means that not all the special shifted symbol characters available on the Qwerty MDI panel are available on the OMG panel. However, setting system parameters 13115 bit 4 and 13115 bit 5 to a 1 allow the missing symbol characters to be entered using Operation soft keys. Other than that, the same keys that were available on the Qwerty MDI panel are available here, just in different locations. Here are the function keys, here are the cursor keys, Here are the edit keys, here is the shift key, and here is the reset key. When the 8.4-inch display is used, a smaller integrated ONG MDI panel is the only MDI panel available. With only 12 true alpha keys available, the shifted states on all of the keys are used for other letters. Now the operation soft key method is the only way to enter many of the special symbol characters. Since we only have 5 main soft keys on the 8.4-inch display, we use the continuous menu key to page through the characters available. Again, the MDI keys are located to achieve the most logical grouping in this smaller area. Here are the function keys, here are the cursor keys, here are the edit keys, here is the shift key, and here is the reset key. Some legacy FANUC CNCs may have a slightly different arrangement, but they all function along the same lines. This completes this tutorial on an overview of the MDI panel. Next we'll provide an overview of the machine operator panel.